Hey everyone, welcome back, PyLadies Rivers community. I am absolutely thrilled to have you here for this explainer on Python functions. Today, we're zooming in on a really crucial concept, variable scope. Now, if you're an absolute beginner just starting out on this coding journey, maybe you're typing away on your Android phone using PyDroid, or you're on a laptop using VS Code, you are in exactly the right place. In our last lesson, we tackled how to create basic functions, right? Well, today, we're going to learn exactly how Python manages the information tucked inside those functions.
So, picture this. You've got a variable named name sitting outside of a function. And then you make another variable with the exact same name, right inside the function. When you tell Python to print name, which one is it going to use? Or what happens if you create a variable inside of a function and then try to use it outside? Can a function actually change a variable that was created completely outside of it? These are fantastic questions, and understanding the answers is literally the key to writing bug-free code. To get us there, we've got a really clear, step-by-step roadmap for today's explainer. We're going to define what scope actually is, compare local and global variables, explore something called the shadowing effect, learn how to modify global variables, uncover the LEGB search rule, and finally wrap it all up with some best practices and common beginner mistakes. All right, let's start right at the beginning with Section 1, What is scope? Understanding visibility. Okay, so in plain English, scope simply determines where a variable is visible and usable in your code. Just think about it for a second. Suppose every single variable in your program could be accessed and changed from absolutely anywhere. If you had hundreds of functions modifying the same variables, you'd end up with complete chaos. Scope is really just Python's way of keeping our variables strictly organized so they don't accidentally overwrite one another. To really wrap our heads around this, think of a variable as a person working in a big office building. Some employees work only in one specific department, say HR. People outside that department can't just stroll in and easily access their internal files, right? But then you have the receptionist at the front desk. They can assist everyone in the whole building. Variables behave in exactly the same way. Some are available only inside a specific function, while others are available to your entire program. Which brings us right into Section 2, local versus global variables, and where these variables actually live. Let's ground this concept with another real-life example. Imagine a school. A teacher writes today's attendance on a piece of paper. Only that specific teacher uses that sheet. It's completely local to that one single classroom. Students in other classrooms down the hall, they have no idea what's on it. That attendance sheet is a local variable. But the school's name, like PyLadies Rivers, is known by everyone, everywhere in the building. That is a global variable. So when we directly compare the two, there's a really clear difference. A local variable is created inside a function. It is temporary. It only exists while that specific function is actively running, and it's accessible only inside that function. A global variable, on the other hand, is created outside of any function. It's accessible throughout your entire program, and it sticks around until your program finishes running. Let's look at a super simple code scenario. Think of it like a bright idea contained in a single room. If we create a function called greet, and inside it we create a variable named Ada, when we tell it to print name and call the function by typing greet parentheses, it outputs Ada. Everything works perfectly. Why? Because the variable name exists safely inside the local scope of that greet function. But what happens if we try to print that local name variable outside the function? If you just type print name outside of greet, boom, Python hits you with a name error. Because name was created inside that specific classroom, outside the function, Python has absolutely no idea what you're talking about. The variable simply doesn't exist out there. And that leads us perfectly into Section 3, the shadowing effect and how it results in hiding global variables. Imagine two identical objects overlapping. It's kind of like wearing a jacket over your shirt. The shirt's still there, you just can't see it right now. If you have a global variable named Grace outside and a local variable named Ada inside, Python looks at the nearest one first. The local Ada temporarily overrides or shadows the global Grace while you're inside the function. It hides it, which actually protects the global variable from being accidentally changed. But hey, what if you actually do want to change it? Let's move to Section 4, modifying global variables. Let's say you have a global variable, count equals 10. Inside a function, you try to add 1 to it by writing count equals count plus 1. If you run this, you won't get 11. Instead, it throws this super intimidating unbound local error. Why?
Well, the moment you try to assign a value with the equal sign, Python just assumes you're trying to create a brand new local variable called count. But wait, you're also trying to read count to add 1 to it. Python basically gets confused because this new local variable hasn't actually been created yet. So the fix for this is to explicitly reach outside the function's little box. If you intentionally want to modify a global variable, you have to ask Python for permission using the global keyword. By writing global count as the very first line inside your function, you're essentially telling Python, hey, do not create a new local variable here. I want to use the global one that already exists. Now, when you run count plus equals 1, the global count safely updates to 11. Now, a quick word of caution here for absolute beginners. While the global keyword definitely works, professional developers try to use it very sparingly. Imagine building a banking app or calculating school fees. If every single function is secretly modifying global variables behind the scenes, it becomes literally impossible to track down where a bug came from. A much safer, much more professional approach is to pass information into your functions using parameters and then return the updated values. It just keeps your code predictable and so much easier to test. All right, it is time to uncover the secret formula. Section 5, the leg search rule, and exactly how Python searches for your variables.
Okay, so imagine you lose your phone. How do you find it? You don't just start by searching the entire neighborhood, right? First, you check your pocket. If it's not there, you check your bag. Still missing? You search your room. And if all else fails, you ask everyone in the house. Well, Python uses this exact same logic to hunt down any variable name you type in. It starts close to home and gradually searches farther and farther away. And this perfectly illustrates the LEGB rule. The L stands for local. Python first checks inside the current function, just like checking your pocket. E is for enclosing. If it's a function inside another function, it checks the outer one, kind of like checking your bag. G is for global. It checks the variables created outside all functions, searching your room. And finally, B is for built-in. Python checks its own built-in names, like print or len, which is like asking the whole house. Local, enclosing, global, built-in. LEGB. Let's move into our final section and see how all of this builds into your real-world coding. Section 6, best practices and the common mistakes to avoid.
Look, as you're typing away in PyDroid or VS Code, you're going to encounter bugs. It is perfectly normal. But here are the top traps to watch out for. If you use a local variable outside its function, you're going to get a name error. If you try to change a global variable without that global keyword, you'll hit an unbound to local error. And if you just throw all your variables into the global space because you don't want to deal with scope at all, your code will quickly become a tangled, really hard to maintain mess.
So, to write clean, professional code, always prefer local variables. Think of them as your safe, temporary scratch pads. Use the global keyword only when it's absolutely necessary. Instead of changing globals, get into the habit of passing info through parameters and returning the values. Keep your functions small, keep them focused, and for sure, always use descriptive names for your variables so you don't confuse yourself later. You guys have done incredible work today. You now understand exactly how Python organizes data, the absolutely critical difference between local and global scope, and that powerful LEGB rule. Coming up in part 3 of our Week 5 lesson, we are going to put all of this together with real-world examples, advanced debugging techniques, and of course, your Week 5 assignment. So, I want to leave you with this final thought. Now that you have this new superpower to control exactly where your variables live and how they interact, how are you going to use it to structure your Week 5 PyLadies Rivers mini project? Keep practicing, keep coding, and I will see you in part 3.